Okay, so P4.4 component characteristics continued. Last lesson, key thing was the lower the gradient on a current voltage graph, the higher the resistance. And that made us notice that we had this curve here for a filament light bulb. As it got hotter, the particles vibrated more, which made it harder for the electrons to go through. So the resistance increased, so the gradient decreased. That's the first thing. Now I want to talk to you in this lesson about three other components which we've already discussed when we did the components topic, and they were the diode, the thermistor, and the LED. Okay. Oh, and the light dependent resistor as well. Let's do four. Let's go for all four. So first off, let's go for the light dependent resistor. So you should be able to remember what the symbol is for a light dependent resistor. So remember, circles means it's to do with light. Rectangle means it's to do with being a resistor. And then it's dependent, which means that the arrows are going to be going in. So that's a light dependent resistor. Let's have a look at what the graphs are going to look like for that. Okay, so inside a light dependent resistor, what you've got is you've got a plate that looks like this, and there's a small gap between that plate, and when the light comes in and hits that plate, it causes an electron to be emitted to the other plate, and that decreases the resistance, because the more light you've got coming in, the more electrons you've got going across that gap. The more electrons you've got going across that gap, the easier the currents flow in, the lower the resistance. So what you need to know about a light dependent resistor is the more light equals lower resistance. Okay, so how's that going to look on our IV graph? Okay, so if the amount of light stays the same, then the light dependent resistor will obey Ohm's law. And remember what we said about Ohm's law was, if the amount of light stays the same and it obeys Ohm's law, then the gradient will be a straight line. So we know that on our IV graph, that if the light stays the same, so that's constant light, then you're going to have that. Now, if there is less light, then the resistance is going to increase. So this is light dependent resistor, LDR. Okay, so on this one then, that's telling me that this one has got low light levels, or dark, equals high resistance. And that's shown by the low gradient. And equally, if it's in bright light, then you're going to get a lower resistance, so a steeper gradient. Okay, that's the LDR, and it tends to be used for things like light sensors. So if it gets dark, then it can make lights come on, or it can tell you how dark it is outside, to know when to come off at the cricket, all sorts of things like that. So anything where you want to know how dark or how light it is, and you can use that information to make your circuit respond to how light or how dark it is. Automatic headlights on a car, for example, anything like that. Right, okay, so the next one I want to talk about is one called, and it looks like this. So it's got a circle, it's got a triangle, and no, just, yeah, okay, and it's got like that. Okay, so we know that the circle means it's to do with light, the triangle means that it is to do with, this is diode, and the arrow is going out, so we know it is emitting, so light emitting diode, LED. And the graph I'm going to show you now is true for all diodes. Now remember, the key thing I said about diodes was that they only let current go in one direction. So this time, this is one of the first ones where it does matter whether it's positive or negative, okay? So this is your I, this is your V, this is your I, this is your V. And the only difference is that this is positive, this is positive. So let's do that bit to start with, okay? And this bit is negative, and this bit is negative. Okay, so if it is plugged in the wrong way round, there will be 0 current. Okay, now can you see that that has got a completely flat line? So that means that the resistance is infinite. Current. So current equals 0 because it doesn't let it go. It completely blocks it. That's the whole point of the triangle shape. It completely stops it going in that direction. Okay, now let's have a look at the positive direction. What happens next? Well, what happens is it doesn't go up straight away. Okay, so my graph looks like that. And as you can see, that the gradient is increasing. So we know that the resistance is decreasing. Okay, gradient is increasing, so resistance is decreasing. And you need to know that the switch on voltage, which is when it starts to go up, is about 0.7 volts, and that's just so the point at which it starts to go up is about 0.7 volts. So if that's 1 volt there, this bit here is 0.7 volts, and that's where it just starts to go up, and that's in the activation voltage. So that 1 volt, this bit here, 0.7 volts, just starts to go up, activation voltage, and you notice that the gradient gets steep really fast. It's really fast, the resistance drops really quickly. Okay, next one. Next one I want to show you is called a thermistor. So, the fact that it's a thermistor has given you a clue as to what shape it's going to be. That's right, it's going to be a rectangle, that's a type of resistor. Now I haven't shown you this one yet, but it looks like this. And it's got a line going through it, and it's got a flat bit. And it doesn't matter, you can rotate that however you want. It is still a thermistor. It doesn't matter how you do it, as long as you've got a straight bit and a flat bit, that's a thermistor. And what a thermistor is a thermistor is a component where you've got 2 bits of metal which are really close together, okay? And then when you heat them up, when they get hotter, what happens is they expand. And when they get hotter, they expand, which means that they are touching more, okay? So they get closer together when they expand. If they get hotter, they expand, they touch more. So that means that hotter they expand. So the gap gets smaller. So resistance decreases. Okay. and conversely, if they're colder, the gap gets bigger, so the resistance increases. Okay, so how does that look on a graph? Well, you should be able to tell me now. Got my normal IV. If the temperature stays the same, then they're just a normal resistor. If they're just a normal resistor, they obey Ohm's law. So that is at a constant temperature. That's my resistance. If I make it hotter, then the resistance decreases, so I get a steeper gradient. If I make it colder, then I make it harder, because there's a bigger gap, so I get a lower resistance. So this is my I, this is my V. This is cold equals high resistance. This is hot, and that equals low resistance. Okay, because you've got these two plates that when they heat up, they expand, which means they touch, which means the resistance decreases. That's all of the strange components. So you might use a thermistor to tell your boiler when the central heating should come on, because the resistance will change in response to temperature. You might want to do it to have like a temperature probe to see if your food's cooked, or you might want to see if your bath's at the right temperature, whatever it might be, where you want an electrical device to know what the temperature is.